Ultimately, the whole thing is do your hazard assessment, wear the appropriate PPE. That's what it comes down to.
Okay, hey everybody, thanks for joining us on the Electrical Safety Podcast. My name is John Travis, I'm your host, and today I'm speaking with Tony Bedford. Tony, thanks for coming on the show.
Oh, you're welcome, John. No problem.
Yeah. I guess we always like to just kind of start by getting a feel for everyone's background and, how they got into sort of the electrical world. And so, yeah, if you wouldn't mind, you can go back as far as you'd like and just kind of start how you kind of ended up where you are today.
Well, when we built Stonehenge, is that how far you want to go?
A little bit more recent, maybe.
Well, I started my apprenticeship in 79, so I've been in the trade for 45 years, I guess, this year. I literally walked in off the street. It wasn't my plan to become an electrician, but I needed a job, so Saskatchewan was booming at that time. So I just walked into the local IBEW office and asked for a job, and they said, "Well, we don't hire, but here's the name of our guy," and they gave me Alvin Archuk's name at Comstock Electric, and I went down there, and he hired me, and the next thing you know, I'm on my way down to Southwest Saskatchewan to the Karnak Poplar River Power Development down there, and I spent a year down there. But yeah, that's how I got started. It was purely out of the blue.
Yeah, so not a lifelong dream, but
no, not at all.
So obviously this is an electrical safety podcast. When did safety start for you to kind of be something that you would think about, or maybe you started paying attention to it a little bit more?
Well, I guess I always did try to work safe, but when I started in 79 and all through the 80s and most of the 90s, things like arc flash weren't even mentioned. Like nobody talked about arc flash. Mm-hmm. And like literally nobody talked about it. It was like what you mean switchgear can blow up? Nobody mentioned anything like that. And as far as electric shock was concerned, you were just expected to get shocked as an electrician. That was part of the job. I think I mentioned to you earlier that one guy, when I was still an apprentice, one of my journeymen told me that it was good for your brain
to get a shock.
And another guy told me that you kind of get immune to it over time. It's kind of like getting measles or something. You get vaccinated.
Yeah. Well, you might start to lose sensation and feeling. So if that's what he means by immunity, but
I guess I don't know. I had one employer. This is me and him, just a one man, one van outfit, and he. I tell this story in my classes, but my first day with him, we drove out to a mobile home park on the outskirts of Regina, and he wanted to see whether SAS Power had connected the meter base that we were working on. And he took the cover off the meter base and he stuck his fingers on the lugs of the incoming side of the meter base like this to see if they were hot, and they were. He got a bit of a belt. He says, "Yeah, they've been here," and that was how he tested for voltage.
Wow.
So the problem with that, of course, is that I got into the habit of doing that myself. I figured if my employer is doing that, then it must be okay.
Yeah.
So yeah. But as far as being safe is concerned, I can't say that there was a work culture or a work safe culture like there is today. Especially I think Westray and Bill C-45 and all of that legislation that followed after that has made a big difference in the industry. A big difference.
Right. Yeah. So you didn't spend your entire career as an electrician. Um, at one point, were you working in maybe supervision or a foreman level?
Yeah, I was a supervisor a few times. I was a production supervisor of all things at Lafarge in Richmond, and then I started my own company for a while. I was actually Scotford Electrical for about 11 years,
Hmm.
and I was doing automation and control, light industry, light to medium industry, that kind of thing. And then I went up north to uh, the mines in the Northwest Territories, first as a contractor or subcontractor, I should say, and
Hmm.
then later as an employee. And I was electrical maintenance supervisor up there. And then later at a mine in BC here, I was electrical maintenance supervisor.
Yeah. So when you get into that supervisor role, um, I'm assuming that you start to think a little bit differently about safety. You're more concerned with the people that are kind of doing work underneath you. Did you find at that time that you started to focus more on maybe what the regulations are, what the standards are, and your responsibility as a supervisor, or how'd that
Yeah,
kind of play out?
yeah. I mean, I was primarily concerned that as a supervisor was my primary concern for the guys who were on my crew, that they were working safely and that they had the tools and the knowledge to work safely, you know. And
Hmm.
it was about that time, I guess, about 2011, I would say that, well, maybe a little earlier, 2008, that the JHA started to come in, what they call a job hazard assessment or
Hmm.
JSP or SLAM card or 5 point card or whatever you want to call it. They're all basically the same thing. And it was a requirement, it became a requirement for any employee to, before they started the job, to fill out a JHA, to fill out this pocket card.
Yeah.
And if the job was a little more complex or a little more, or a little less routine, I should say, then it was, you would fill out something a little more complex, like a JSP, a job safety plan. And you would have a job briefing and all that kind of stuff. But yeah, as a supervisor, I became more concerned about the safety of the guys on my crew. And towards the end of my career there, just before I retired, that was my aim, to make sure that the guys on my crew were working safely, for sure.
Hmm. How did you find the response from the crew?
Uh,
Um,
it varied, you know. That's the funny thing, but mostly they were positive. Mostly guys on the crew were positive, especially after they got over the initial suspicion. You know, when you when you move into that role and they don't know you, you sort of have to win their trust. And once they realized that I was, you know, genuinely concerned about their safety, then that sort of trust element came into it, and they began to be more concerned about their own safety and coming to me with concerns uh, that we could address together. They're very much so. The idea, you know, I mean, at least part of the legislation is that um, you have the right to refuse unsafe work. And there's a process, you know, you can't just refuse to do something because you don't want to do it. But if
mhm,
you genuinely believe that what you're being asked to do is unsafe, then there's a process that you can go through. And once I convinced them that I wasn't going to dismiss their genuine safety concerns, then they started coming to me with those concerns, and we would go through the process.
mhm.
And occasionally I would get pushback from upper management, but for the most part, they were on board. Upper management were on board with what I was doing. Yeah, yeah,
Yeah. Did you find that, because this is something I still see, maybe not a lot of, but it does come up with, you say upper management, but kind of a disconnect between um, like what the risks actually are, what an arc flash is, how it happens, shock. A lot of confusion around that. Like in your experience, you know, did you find that challenging, like going to the management group and kind of getting buy-in, getting them to support different activities you're trying to do in safety? Or did you feel that the people you worked with, genuinely understood arc flash and electrical safety?
If there were, if my, let's say my immediate supervisor, electrical general foreman or senior electrical supervisor, they would understand the risks usually.
Mm-hmm.
But as you get further up management, when you start getting into people who come from, say, a mechanical background, people like mine maintenance superintendent or even mine manager, where you start getting into people who are more administrators than anything else. They may come from a mining engineering background. But as you get further up that chain, uh, I don't know, perhaps I'm doing them a disservice, but safety becomes more of an abstraction than a reality because they're focusing so much on other aspects of the job, or aspects of the operation of the or operation of the mine or whatever, that they're more focused on that than they are in the specifics of what arc flash is or the specifics of what electrical shock hazard is. That is dealt with more at the frontline supervisory level, which is what I was.
Mm-hmm.
And that next level, which would be, like I say, general electrical foreman or senior electrical supervisor or superintendent. After that, like I say, it becomes more of an abstraction. So you need to have
Mm-hmm.
that sort of second line supervision in on board. They need to recognize that the people above them may not understand what it is that they're talking about. And I
Right.
think that sort of training should actually be extended. I really do. It's fine to have training for your guys in the trench. The guys who are doing the work. It's fine to give them a certain amount of training, but I think that should extend up the line. You know, the general foreman may have had the training, but it should go even further than that. The mine maintenance superintendent should maybe be sitting in an open session,
Yeah.
because they may not be exposed to um, the everyday hazards. Well, they're not. They're not exposed to the everyday hazards that a frontline electrician is going to be exposed to, and they may not have
Mm-hmm.
even seen any of these videos that become part of any presentation. Like the presentation that you guys have. I've got some pretty graphic videos of what it's
Yeah.
like to be in an arc flash. And I think that they would get a sense of what it is that we're talking about when we're talking about electrical safety.
Yeah. No, the reason I ask is I do see, I see some emails and have some conversations, and there just seems to be a real lack of understanding after you get to a certain level where, that it just there's no connection there. So that's a great idea. Maybe getting some of those people into some training, some awareness training to see, what the consequences of these things actually are. Um, you mentioned when we were chatting earlier that you did have an incident, an arc flash incident that you were sort of a part of.
Yeah.
Could you walk us through that story? Or
Well, it just occurred at a mine in the Northwest Territories when I was actually, what had happened is the mine had closed at this point, and we were on care and maintenance. I was part of the care and maintenance crew. I mean, I was still technically electrical maintenance supervisor. That's what my job
Mhm.
title was. But I mean, there was really just myself and two other guys. So we worked together to solve problems. And we did have an arc flash study done at the beginning of the life of the mine. So a lot of the equipment already had arc flash stickers on there, stating what
Yeah.
the incident energy level was, et cetera, et cetera. But there was one particular PDC that had been a power distribution center that had been put in when the camp was built, when the mine was being constructed. And it was old. I mean, I would date this thing back to the 70s. And we're talking 2013 here, 2014.
Mhm.
So, I mean, this piece of equipment was old. It had not been maintained, but it did at that point. It fed two particularly critical pieces of infrastructure. One was the mine, was the primary mine water or auxiliary mine water treatment plant, is what they called it.
Mhm.
And the other was the sewage treatment plant for the mine. And this equipment was supposed to have been replaced at some point when the camp was deconstructed, but it never was because one thing and another. Anyway, when we had the arc flash study done, the engineer that came in had put incident energy levels on all the equipment in the mine except for that one thing, and she said, I can't rate this thing. It's a bomb, you
Right.
know. And one night I woke up in the middle of the night and the powerhouse wasn't running, which is not a good sign. And I thought, oh, the phone's going to ring, and it did. It was the powerhouse operator saying that we lost the powerhouse because of load shedding, and could I investigate? He got the powerhouse back up and running, so we had lights and power. But what we discovered is that the auxiliary water treatment plant and the sewage treatment plant were black. So we went out to this PDC and a breaker had tripped, a 600 amp, 600 volt three phase breaker on this PDC had tripped. And I broke out the megger and the meters and all this kind of stuff. And we isolated at the substation. And the substation had actually tripped, is what had happened. And we did our lockout. We did some tests on this PDC, and the only thing that we could find was that one of the legs of the three phase that went out to the water treatment plant was measuring 4 mega ohms to ground, which is low, but it's not a killer. And actually,
Mhm.
that kind of at that point it explained why we were getting ground faults on the substation that fed this particular PDC. So I thought, well, 4 meg, well, we can deal with it. But here's the deal: this thing was in really, really bad mechanical condition. Like I said, panel over the years, panels have been taken off, not replaced, and they were lying over in a corner, and covers. And I said, okay, before we fire this thing up, here's what we're going to do. We're going to take the time. We're going to basically rebuild this thing so that if something does happen, any arc flash that might occur is going to be contained. So we're getting a little pressure from not too much from the guy who was the crew chief at that time, or the superintendent at that time, because of the fact that the water treatment plant and the sewage treatment plant is down. So
Mhm.
I sent a couple of guys to start pulling alternate feeds for this, and in the meantime, myself and another couple of guys, we started putting this PDC back together, which we did. It took a few hours. We had to drill and tap and all kinds of things, find bolts, but eventually we did get this thing back together. And I thought, well, we don't know what this is rated at, so we're going to use the 40 cal suit here. We're going to get the Cat 4 suit out of the powerhouse, and that's what whoever's throwing this breaker, whoever's going to close the breaker, is going to be wearing that. So one of the guys said, yeah, I'll put that on. So we dragged it out to where this PDC was. This was in a little shack, basically a 10 by 10 room uh,
Mhm.
with just this PDC in it. Everything else in that room had been taken out when the camp was pulled out, except for this PDC. Anyway, so he put on the 40 cal suit, and myself and the other guy. Now, in 2020 hindsight, we shouldn't have been in there, but we were, and we had on our Cat 2 stuff. Plus, we both had on. It was very cold that night. It was sometime in December and January, and I remember it being like minus 30. So we had on our Cat 2 stuff, and then we had on Cat 2 insulated coveralls, and then we also put on a parka over top of this, which was also rated, ARC rated at Cat 2. So we had multiple layers, and then the guy in the Cat 4 suit got down on his hands and knees, because these things are always at the bottom of the PDC. And the other guy and I, we went over in the furthest corners of the room, turned our back, and closed the breaker, and there was a hell of a bang. It was, I describe it as having somebody firing a shotgun off in your ear. Oh, that was the other thing. We were all wearing hearing protection. And the room filled with flame and smoke. And my first thought was the guy down at the base of this PDC turning on the breaker. And I turned around and I said, "Are you okay?" He was already out the door. Yeah. And so was the other guy. It was kind of a Laurel and Hardy thing, as they both ran out the door. And me being me, I stood there looking at this thing because the color of the flame was amazing. It really was. I've never seen that. The closest I could think is when I worked in the nuclear industry back in the day, and I was watching the spent fuel bundles come out of the spent fuel machine into the spent fuel bay, and they glow this weird purple. And it was just like that. And finally, the superintendent says, "Get the hell out of there." Yeah, I better. So I ran out the door too. But we were all okay. All three of us were fine. That Cat 4 suit protected the guy who closed the breaker, and the Cat 2 stuff, the layers of Cat 2 stuff that myself and the other guy had on. Well, they saved our bacon.
Mm-hmm.
And the fact that we had rebuilt the PDC so that the majority of the arc flash was contained in this old PDC.
Yeah. Yeah. So did you ever figure out what caused the arc flash?
Yeah. What destroyed? I mean, this PDC was destroyed, right? It was done. There was no way that we were bringing this back from the dead. But we hauled it out of there. We did have a spare, which we, over time, we managed to get back in there. But we got it into the shop, and I took it apart myself because I wanted to see what it was that caused the problem. And what we found is that the vinyl insulation on the bus, because the bus work is so close together, this PDC was very compact. The bus work was so close together. The manufacturer had coated the bus work with vinyl coating. And because no maintenance had been done, no infrared scans had ever been done on this thing, because nobody considered it to be a vital piece of equipment. No one detected that this breaker that had tripped and eventually exploded, over time, the connections, the lugs, had loosened because of thermal expansion and contraction to the point where they had overheated. That vinyl coating on the buswork then had carbonized. And there was a little, and it had burned away slowly, and there was a little piece of, which was still there. There was a little piece of this vinyl that was almost in contact with the other bus, with the exposed bus. And I suspect that what happened is when we closed the breaker, it arced that very, very small gap. It was probably about 1/8 of an inch. And that's what started the whole thing. But Again, 2020 hindsight, if I'd have brought out the high pot tester with the 10,000 volt setting, we probably would have found it, because we probably would have either seen it arc or heard it tick. You know how it ticks when it arcs across? We probably would have heard it, but I didn't think to do that. I just went with the mega and a voltmeter.
Right. So you checked it out, but thought everything's good here. Maybe not good, but better than not going to blow up.
Yeah, like
And,
like I saw that we saw that 4 meg on that one phase
right.
to ground, but I thought, well, that really shouldn't cause a breaker to trip. That would cause a ground fault on the substation that's feeding this thing, right? Because there was a neutral grounding resistor on that substation that would have alarmed, and occasionally it did. At least twice a rotation, that thing would go into alarm. It wouldn't trip, but it would alarm that there was a ground fault on the system.
Wow, that's a really it's an interesting story, because there were really not that many mistakes made. It could have been a lot worse had you not chosen to wear PPE. I mean, obviously, you could have been out of the room and only the one person in there doing the switching. But, and then you said you could have used, some different testing methodologies to maybe find that. But that's often the case with incidents. There's something that almost no one would have predicted that's about to happen. And that usually you can't change. And that's why it's so important to have, your risk assessment done and thinking about, well, should we be wearing PPE? And, even though you didn't know the incident energy level, you knew it was going to be bad. So he was in the 40 cal suit. Arguably, all three, it could have been in a 40 cal suit when you don't know what it is, right? But all in all, that's a pretty good story that kind of shows, I guess, how powerful some of these procedures are, really, like how helpful they are. So, no, that's great.
Well, I have no doubt that had we not put that piece of equipment back together in some semblance of order, and we hadn't have taken the precautions that we did, I have no doubt that the guy who closed the breaker would be dead, and myself and the other guy would have been severely injured. I have no doubt of that.
Yeah. Well, I think that's a pretty good place to end it, Tony. I mean, that was a great story. I didn't know that it happened to you, and I want to thank you for coming on the show.
Oh, you're welcome.
I think people will get a lot out of that. And yeah, I mean, is there any final thoughts that you had, or maybe if you had somebody who wanted to reach out and ask some questions, maybe where they could find you?
Well, they can, if they want to contact me, they can contact me through you, right? Through Leaf Electrics.
Yeah.
I'm also on LinkedIn if somebody wants to go that way. I'm doing these online courses for you, and one of to me, ultimately, the whole thing is do your hazard assessment, wear the appropriate PPE. That's what it comes down to, and that's about the bottom line right there. That's the message. Do your hazard assessment, wear the proper PPE.
Perfect. Okay. Thanks a lot.
No problem. Okay. Thanks, John.